And I think we're live. Cool. Good morning, everyone, and welcome to your first lecture at WITS. We are the Teaching and Learning Committee of Computer Science in the School of Computer Science and Applied Maths. And we want to welcome you today to just a bit of an introduction. We're going to talk a little bit about the structure of the program, introduce you to the school a bit so that you can kind of meet some people and see who it is that's going to be teaching you. Usually we would be spending this time sitting in a classroom together. We'd all be together and we'd get to meet each other. Unfortunately, due to COVID, that's obviously not possible at the moment. But we thought that this would be a good opportunity, at least, to still try and give you a little bit of a taste of what computer science is like, what it's about, who your lecturers are, and who you're going to be involved with going forward. Yeah, and hopefully that once you've met us, that emailing us back and forward and having consultations and meetings, that isn't a hard thing to do. We realize that it's a little bit difficult given that you won't be meeting any of us face-to-face for quite some time, and also that you won't be meeting any of each other face-to-face for a while. And we think that it's always a really important aspect, making friends at varsity and having a lot of fun with people who share similar interests in academics and other social events. So we're going to be breaking everyone into TUT groups and things throughout the year to try and encourage us. And we really encourage you to chat to the other people in your TUT groups, chat with your tutors and everything. Try and be as social as you possibly can, given the state that we're currently in. So I'd like to introduce everyone else that is here today. So my name is Dr. Richard Klein. I'm the undergrad coordinator for the BSc Computer Science. Also in the stream with us today, we've got Brandon Ingram, who is the third year coordinator. We've got Dr. Hiram Bao. She is the honors coordinator. We've got Stephen James, who is now Stavovo James, who is... he is the first year coordinator, and we've got MJ here from the mathematical sciences labs as well, who's going to be speaking here too. I see, actually, we have two more entries coming in. There we go. We have Dr. Pravesh Ranchard, who is here as well. And then the head of school is here, although there seems to be an issue with the device. Cool. Okay, cool. So we'll come back there. Yeah. So once again, welcome to everyone. We will have just a brief intro from the head of school as soon as we're able to get that connection up and running. Then following that, we'll continue and we'll just chat a little bit about the structure of the program and things going forward there. While that is then being figured out, let's then go here. I'm actually going to share my screen. There we go. Cool. Okay, so in the meantime then, so this is the undergraduate outline for computer science. This undergrad outline applies to every single course that you'll be taking in this program. And so we will make it available. It's going to be available on our online system, and we'll explain how to access it and everything. And this has quite a few of the different rules. It tells you who the coordinators are and has their contact details if you need to get in touch with them, as well as just the outline of the program in general. Cool. So I'm just trying to sort out that other connection. Cool. Okay. So what is computer science? I think that's perhaps a good place for us to start. And really, when we talk about computer science, I'm sure that a lot of people here are already thinking of the big things that we care about here, right? And so I imagine that the first thing that comes to everyone's mind is something. It'll either be hacking, or it will be app development, or it will be AI. And all of those things are important core aspects of computer science, right? And those are things that you will be learning along the way a lot in this program, right? And so one of the kind of overall structure that you'll find as we start off is within computer science, it's this idea of the science of computing. It's about problem solving, and often we're using computers to solve these problems, and we're saying, how can we come up with solutions to these problems, like algorithms, that we can then code in languages that computers can understand, and that they can hopefully solve these problems quite efficiently. And there'll really be a strong focus on algorithms and programming, particularly in your first 2 years, where you'll do a lot of courses that relate to, I have a list of them here, where you'll be doing a lot of courses that relate to, for example, the structure of computers and how they work. So within basic computer organization, you'll be looking at the specific modules within the hardware of a computer. What does the hardware do? How do those things all fit together? How would you build a CPU, and then how does it kind of actually run the things that it runs, right? Later on, then in Introduction to Algorithms and Programming, and within Introduction to Data Structures and Algorithms, you'll then have a very strong focus on algorithms specifically, and on programming, and how to write efficient code, and how to make sure that you've got code that's correct. In the Discrete Computational Structures one, you'll then focus a little bit more on a new type of maths. So at school, you've done calculus and algebra so far, and you can imagine how that relates to, if you think about calculus, it's very much about like continuous numbers. And in computer science, because we're often working with digital computers, we often work with a more discrete kind of maths. And so you'll find that in that module, we teach you a little bit about this new type of maths, and how to proofs and things around it that you can then use to show later on that your algorithms and your code is correct. So at the moment, everyone who's taking the BSc Computer Science should be registered for all 4 of these modules. The codes that we have here, these ones are for the full-time program, these ones are for the part-time program. So everyone should be registered for 4 of these, as well as algebra and calculus in Maths 1. You absolutely must be registered for those ones. And then we very, very strongly encourage everyone to be registered for Applied Maths 1 as well, APPM 2006. Although we realized that program filled up, and so some people had to pick different electives. Yeah. Cool. Going forward into second year. The second year program, you have a focus on, there's kind of a programming and app development focus in some of the early modules there. And so there's database fundamentals and there's mobile computing. And database fundamentals is really when you're starting to say, how do we store data? How do we store large amounts of data in ways that we can access efficiently? What kind of language do we use to access that data and to manipulate it in different ways? And then in mobile computing, it's then going to be building an app. And between those two modules, you'll then be doing a large project where you'll build an app, you'll build a database, you'll set up a server and get all of those things running. And yeah, that's usually quite a fun exercise there. In the second semester of second year, you end up with computer networks, and we're really trying to say there, how do computers communicate with each other, right? So we've all heard of the internet, hopefully. I'm going to be using it a bit this year. And so the idea of computer networks is really to look at quite a low level and say, how does the technology work that allows computers to communicate in this way, right? And so when we can physically connect them, there must be protocols and languages that computers can use to speak to each other. And then how do we use those in order to get programs to do more complex things on networks. And then finally, in second year, you'll also be doing analysis of algorithms. And that one's really a continuation of the kind of algorithms component in first year. And in this analysis of algorithms one, you start to say, how can we prove that an algorithm is correct? How can we ensure that it does what we think it does and that it actually solves the problem that we think it's solving? And more specifically, how can we do it in a way that's efficient, right? And so how do we measure the efficiency of an algorithm? We do that in terms of the amount of time it takes to run or how much resources it needs. So for example, we could have an algorithm that takes a list of new first-year students at WITS, and let's say we want to sort it by alphabetical order, right? That's maybe a sensible thing to do. And if we have a list of 100 people, then it's not so bad, right? So it's quite doable to kind of sort that list of numbers, that list of names. But as that list grows and grows and grows and grows, then we find that a lot of these algorithms start to get much, much slower. And you can imagine that if you now have, let's say, all the students at WITS, right? So now we're talking about 35 or 40,000 students. Suddenly to sort that list takes a lot longer. And so you want to have really, really efficient algorithms that will allow you to process much larger amounts of data, right? Within the analysis of algorithms course, you'll also do some graph theory, and you'll look at algorithms, for example, where you can solve like the shortest path problem. You might be building your own Google Maps one day, and these are the kind of algorithms that you might want to use there. And so really there'll be a lot of focus on that. In second year, you should also be taking maths too. And you'll see that we've listed some of those topics there, but I'm sure that you'll come back to us and ask us what those are at the time. So we'll skip maybe then down to third year. So in our third year program, we have two majors. So in your kind of Bachelor of Science, right? So in a BSc, right? The way that it's structured is that you'll be here for 3 years, hopefully, right? And so in first year, you need to be So in first year, you need to be taking 4 first year subjects, which are each going to be worth 36 points. In second year, you have to take 3, which are each worth 48. And in third year, you have to take 2, which are each worth 72. And that will give you the credits that you need to graduate. At the end of your degree, whatever these 2 major subjects are, those are the majors for your BSc degree, right? So in the Bachelor of Science in Computer Science, then we have 2 separate majors. So you can double major in Computer Science. In Computer Science 3, so this is the first major, there's one called Formal Languages and Automata. And really, like a formal language is like a programming language, okay? And so we would compare that to something like a natural language where we talk about English or Zulu, right? And so natural languages are what humans speak, but they have lots of like different meanings and they can be very colorful, and it can be hard for computers to understand what they mean. So when we have formal languages, then the language is set up in such a way that there's only one specific thing to do. And so within that module, then you'll be focusing a bit on kind of the design and interpretations of those kinds of languages. After that, you'll be doing software design. So when you want to build really large, complex systems, right, you don't just sit down and start hacking away on day one. The first thing you would do is you would chat to your clients, and you'd find out actually exactly what it is that they need. What do they actually want you to build? How do you build it? And you design it carefully. And in that module, we'll really teach you about that and how to do that yourself. Advanced analysis of algorithms is then the continuation of the first and second year algorithms courses. And again, it's about the efficiency of algorithms and the correctness of algorithms, and really just ensuring that we get code that scales well when we get very, very large amounts of data coming through. And then the last module in Computer Science 3 is operating systems. And so I imagine that everyone here is either watching on, if you're watching on your computer, maybe you're running Windows or Linux, maybe you're on a Mac. If you're watching on your phone, it could be Android, for example. And there's an operating system that runs on your computer that then controls all the resources. It allows programs to ask for memory. It allows them to ask to connect to the internet and send messages to each other and things like that. And so operating systems is then, how would you design your own operating system, and what are all the components that are part of it? And really, how do we make that all work together? In the second major, this one is called computational applications. And there, what we're really talking about is we're talking about more applied methods in coming through from computer science, right? So the first one here, which is an exciting one, is called machine learning. And there, the idea is to say that quite often it's just too complicated to tell a computer to do something, right? So if you imagine that we have a robot and we are trying to get that robot to walk, right? It's very, very complicated to tell the robot, lift up your left leg and then put it forward and take a step. But while you're doing that, you have to balance carefully so that you don't fall over. And like actually writing that code is very complicated. But what we can do instead is, if we can teach a machine to learn, so we can program into the machine that it can learn, and then when it's able to learn, we can just show it how to walk, right? And so you can imagine a robot that stands up, and like imagine a baby, right? If you were a baby and you're learning to walk, right, and you sit there and you're kind of hanging out and everyone's around, and then you're standing and you lift up your foot and everyone looks excited, and you put your foot down and you've taken your first step forward, and the crowd goes wild, and all the adults and parents in the room are excited and smiling and shouting, and everyone's excited, and you get this like little positive reward inside your mind, right? So that would be a hit of dopamine or something. And so you get this positive reward where you say, oh, that was amazing, I'm going to do that again. And so you can almost start to say, well, maybe we can do that same thing, but with computers, where we can give them this kind of positive reward when they take a step forward, right? And then maybe if a baby takes another step and then falls over, then maybe you fall over and you hit the floor, and that's not so fun. So you maybe get that little bit of a negative reward, and you say, okay, like walking is good, falling on the floor is bad, I'm going to try do more of the one, right? And so really machine learning is a very core aspect of what we do. And I think in modern computer science specifically, and if you're interested in artificial intelligence, or if you want to become a data scientist, the techniques and things that you learn within that type of field is going to be really, really important for you as you go forward. The next module here is computer graphics and visualization. And the idea behind computer graphics and visualization is really the maths behind rendering, right? And so we've all seen computer games before, right? I'm sure lots of people have played computer games. So how would you design your own computer game? How would you write the algorithms so that you can render really good looking images, and you can have characters that are wandering around the screen, and you can move the camera? And how do you do that in a way where you have realistic lighting effects and realistic material effects? That maybe how you get like refraction and reflection and stuff coming off of water. And so this is really the maths behind that. How would you get these algorithms to generate the stuff? And the same maths is then used in gaming. It's used in like 3D animation and movies these days. And yeah, that's the graphics module. The next one there is parallel computing. And parallel computing, I guess, is your first introduction into supercomputers, right? And so what you'll learn is throughout this year even, you'll see that computers are not very clever, actually. Computers just do one thing at a time. They have one instruction, and we do that instruction, and then we do the next one, and then we do the next one, and then we do the next one, right? But sometimes when we want things to be really, really fast, it might be better for us to just give that problem to like 400 processors, processes, or 4,000 processes, or 400,000 processes, right? And now you can do 400,000 things at the same time. And so in parallel computing, what you're starting to learn is what are the techniques of programming that allows you to code for so many CPUs at the same time, right? So that will come through on you'll kind of look and say, how do you code for hundreds of thousands of CPUs? But also these days, in kind of on the different side, we see that you also have ways of programming on graphics cards these days. And so we can use things like CUDA and other techniques. And so these are a lot of the things that you'll use in order to say, how do we scale up computing to really, really, really high performance techniques. Okay. And then finally, the last one there is your software design project. And this is a project that will just run for about the whole year or so. And really the idea is to do a project where you have a client, and it's as if you've gone out into industry, and the client will sit there and will say, what are you looking for? We want an app that does this, and we want a server and a website and the database, and all of those things must work together, and you must be able to build that kind of broader software. Okay, so in the chat, maybe just before we move on, just to hit some of the questions that seem like they've come up a few times. My colleagues have been answering some of them as they go, but I see that one of the big ones, the question revolved around what programming languages and things you'll be using. And so in first year, you'll be doing Python for the first couple of weeks. And this will take place in Comms 1018, and your lecturer for that is Steve. And there you'll be learning Python for a couple of weeks, and that will just help you get a sense of how algorithms work, how to think in like a computational way. And so Python is kind of a very nice high-level language that really, it does a lot of stuff for you and allows you to focus on the problem solving. So you'll do that for a little bit of time, and then after that, we're going to move over into C++. And C++ is the opposite, where it will do nothing for you. So Python says we're going to make sure that you're really safe. We're gonna make sure that memory is managed properly, and that you never have like mistakes in your code and stuff like that. C++ is a shotgun, and the advice is to try not to shoot yourself in the foot with it. And so it's a very, very, very powerful language, but it's a little bit more complicated because you have to manage everything yourself. But the fact that you can then manage all those things yourself means then that you have a lot of power, and so you can create really, really powerful and fast systems. Okay, so that's the first year programming. In second year, you will be doing Java. And so you'll be doing Java for Android development, and then later on just kind of standard Java itself in your algorithms course. And then within databases, you'll be learning SQL, so structured query language, which is the language that we use in order to program databases and to work with databases. Yeah. So those are your kind of second year languages. And then in third year, you'll be using Python again. So you use Python in the machine learning course. You use JavaScript in the computer graphics course. You also use C in both computer graphics and in operating systems, I think. And have I missed any of them? I think that's it. Yeah, so I think those are the main languages that you're going to use, and you'll see kind of in third year, it's a lot more flexible in terms of kind of which language you use, and hopefully what you start to notice going on is that most of the languages that you're seeing in this case are the same, where they all have the same kind of for loops and functions and things like that you'll come across. Great. Okay, so I think that the head of school has been able to join us. I'm not sure, Prof, is your connection working? Cool. Great.
Can you hear me though?
Yes, yeah, we can hear you now. Thanks.
I'm actually connecting. I'm connecting using the phone. So.
Cool, great. Okay, cool. So, who've joined us? We have Professor John Cheki, and we have Professor Hima Vadapali. They're the head of school and the deputy head of school. And Prof. Cheki, if you could just maybe give us a few words and yeah, thanks.
Yes, thank you, Richard, for that. I can imagine how much stress our students go through. I mean, I've spent about 30 minutes trying to connect to this technology. Nevertheless, I'm sure that we will be able to overcome these problems as we move along. My job is quite simple, is to welcome the computer science students to the School of Computer Science and Applied Mathematics. And I can proudly say at the #1 university in the country and probably in the whole continent. And here we aspire to uphold best standards, and we have capable, highly qualified individuals in the school, and I'm sure they're going to be speaking to you one by one this morning through to the afternoon. And these academics will travel with you your journey from today. And I hear Dr. Klein saying that hopefully you'll be with us for 3 years. But me, I'm saying, hopefully you will be with us for 3 years for your bachelor's, for another year for your honors, probably for 2 years for your master's, and for another 2.5 years for your PhD, depending on how fast you work. And indeed, we will assist you to realize your own dreams. It's not going to be easy. It's going to be challenging. Some of us will be sleeping in the libraries. We know that there are some students who have funding problems. We know that there are students who have issues with the meals and accommodation and all those things that include finances. And we understand the hardships that our students go through. But I can tell you something, our students are so determined that even through those difficult times, they still get their degrees with high marks, actually. So welcome and good luck for the year and for your career. I sincerely wish you all of the best, and thank you. See you around sometime when COVID is over on our campuses. Bye.
Cool. Thank you very much.
Thank you, Rich.
Cool. Thanks very much for that. Yeah. Prof. Vadapali, do you have maybe any words to add?
Sure. Thank you, Richard. Hello, everyone, and a very warm welcome to the School of Computer Science and Applied Mathematics. I would first like to say well done on making it this far after what was a very difficult and challenging 2020. I'm hopeful that you will have a intellectually stimulating 2021 and beyond. We at KEZAM take our programs very seriously, and be assured that we have put structures in place to help you navigate and have a fantastic university life. That's it from my side. All the very best, and hopefully I'll see you all soon. Thank you. Thank you, Richard.
Cool. Thanks very much. Great. Yeah. Cool. So I'd like to just echo that. The program that you are in is an extremely competitive program, and that we get applications for the BSc Computer Science. We get about 4,500 applications of students who want to get into this program, and we only really are able to accept about 400. And so for those that have made it into the program, you can be very proud of yourself, and you can be proud of what you've done so far. And you all belong here. We have a good process to make sure that the people who are accepted into the program are people that we really believe can succeed in this program. And so we do believe in you, and you've made it this far through a very difficult 2020. And we hope that 2021 will be a bit of an easier year, but we do realize that these issues are going to continue for the foreseeable future. And so in the online learning process, we do want to make it very, very clear that you must please continue to talk with us. If you are struggling, if you're having data issues, connectivity issues, if you are struggling to understand your work or stuff like that, please do get in contact with your tutors, with your lecturers as well, and really just speak to them as soon as there is some kind of issue, right? Usually it would be very easy for us to do this because we'd all be wandering around during the computer lab somewhere, and then you just stop us and be like, oh, I'm stuck on this, what do I do? And we need to be a lot more deliberate about those things now that we are online, and that we will be online probably for the rest of the year. And so please do talk to us, get in touch. The different lecturers may have different approaches to things. In first year at least, we are standardizing on a Discord server, and so there will be a Discord server for each of your modules. And in those Discord servers, you'll be able to chat with your fellow classmates, with your tutors, with your lecturer, and you'll just be able to speak about all those different things. We'll split things up with different channels. For those that haven't used Discord before, maybe I should, I can pull it up. Discord is, it's a platform that mostly, I guess it was mostly a platform that gamers used previously. Let's add this one. So this is what Discord looks like. And you can see it has these different channels that you can chat on, and you can type messages, and you can type code, and things like that. Once we have the tutorial groups that are all set up, you will be added to a specific channel for your tutorial group. You'll be able to chat with the other students that are part of your TUT group. You'll be able to chat with your tutor and your lecturer as well. And so please do make good use of Discord. There are apps for iPhones, there are apps for Android. It runs in the browser as well. There are programs that you can use on Linux, on Windows, on Mac. And so all of these different systems are usable there, right? And so please do use Discord. It runs on basically everything. And then to add to that, when you're just using it for text chat, the amount of data that it will be using will be very, very, very low. Okay, so do feel free to use it. In the case of just using it for chat, it's no worse than WhatsApp, right? It's the same as WhatsApp, and so you can use it like that, and it just gives you a nice platform to chat with everyone. For video calls and things like that, once we've broken you up into the TUT groups, then you will be expected to do regular video calls with your tutors. And depending on your data situation, we will assign different TUT groups using different technologies. And so if you're able to use things like Google Meet, then a lot of the groups will probably run on that. Some of them might run via Discord. And for people who have data constraints, where it's very important that you run through one of the zero-rated services, we'll have a number of TUT groups that run through the WITS Big Blue Button system, which has been zero-rated by a lot of the service providers. Cool. So that gives you a bit of sense on that. There are usually some Telegram groups and some WhatsApp groups that are usually run by the class reps. Those are unofficial groups, but they can be extremely useful. So those are worth participating in as well. But we definitely want to encourage people to be using Discord primarily as the platform to chat. Okay. Cool. Colleagues, I don't know if anyone has anything to add on that one. Happy? Great. Cool. Okay, cool. So that was the chat platforms. The other thing then, which is going to be new for well, I guess everything's new for first years, but the School of Kazam, we do not make use of Ulwazi, right? So Ulwazi is WITS's main learning management system. And so that's based on something called Canvas, and WITS has just moved on to Canvas now. So you'll find in your other classes, you will be, for example, in Nats, you should log into Ulwazi and you should be able to see those modules. As I say, in Kazam, we tend to use Moodle for our systems, and so you are able to access it by going to courses.ms.wits.ac.za. Maybe let me type that somewhere. I'll type that somewhere bigger. We'll make that link available. And when you go to the site, you'll be able to log in with your normal username. And so your username is just your student number, and it's your standard WITS password. Okay. So what you should do is, in fact, you can even do it now if you're watching. Go to courses.ms.wits.ac.za. MS stands for Mathematical Sciences, right? And when you log into Moodle, you should then see a list of all the courses that you're registered for that take place on Moodle. So, for example, at the moment, you will see Comms 1018 and you'll see Comms 1015. So you should see Basic Computer Organization and Introduction to Algorithms and Programming. And so those two modules are up already. And you should already be registered in those modules. If you are not showing up in those modules, please feel free to just send me an email, and then I can help you with that. When you log into the site, you'll be able to see a number of different resources and activities and things that are posted there. And for the programs that are using things like Discord, right, we will paste a Discord link in those courses. Okay, so don't use that one yet. Wait until Steve shows it on the Moodle site. He'll send out an announcement, but that link will then be there. You click on that link, you sign up for a Discord account, and it will let you access the platform. Okay. Cool. So that's Moodle. Moodle itself is it's kind of big open source platform, but we've written a number of kind of custom modules ourselves. And so you'll find that you do a number of assignments on Moodle where they're automatically graded, for example, by systems that we've written. And so please just, we'll be showing you how to use those things and how to submit assignments, how to use all the systems and everything as we go. Cool. So so just to reiterate there, I don't know where the best place actually to type this would be. So we'll just do it somewhere where it's big enough to see. So that's the site that you want to visit. And as I say, if you log in now, you should be able to access everything. You will also find when you log into Moodle that there is a course called Undergrad Kazam. And this course contains just general information, school information that we think is useful across the board. At the moment, it has the Undergraduate Computer Science Outline. So that was the document that I was skimming through earlier, this one. So please do go and read that document in detail. It contains a lot of information that is important to your degree and how it's structured. For students that hold bursaries and need to get their bursars to buy laptops, often they will request an official letter from the school. And so we do make this letter available on that site there as well. And you can download that letter just from that site, right? So please check that out. And we will be adding to this throughout the year as Kazam makes other resources available. There will also be similar resources available for the applied maths program as well. And I believe that you'll be having an applied maths intro lecture similar to this one tomorrow. Cool. Great. Okay. So I think that covers those things for now. Perhaps from here, can we maybe ask MJ? MJ is from the Mathematical Sciences Laboratories, and he works with Sean and Brian, and they run the large computing labs, where in a normal year you would have gone to sit and work and do your lab sessions and things like that. So they run a number of programs, and so MJ is just going to chat a little bit about some of those programs and interest groups, and then maybe after that, Brandon and Steve can maybe just add in regarding the interest groups that they're involved in as well. Thanks. Go for it, MJ.
Hey guys, can you guys hear me? So my name is MJ. I work in the mathematical science labs. As you can see behind me, the process for the mathematical modeling group. Too specific because I'm the one who started those two, but plenty of other interest groups that you students can join. But before we get there, I'll give you a brief overview of the mathematical sciences labs. So as a scientist, you learn a bunch of techniques and a bunch of rules and laws and theorems, but you barely have chance to play around with them. So the labs are created as an environment where you can play around with the things you learn computationally in a safe space, where if you break something, there'll be someone else to fix it. Don't encourage you using a hammer on the keyboard, but we encourage you coding as much as you can, right? So hopefully when we find a way to manage the COVID situation, you guys will have open access to the labs and you can walk in and play around with the computers and make your own programs, make your own bots. I see there's quite a lot of people who want to make their own WhatsApp in the chat, so that's quite good to see actually. Yeah, and we also host a wealth of interest groups. Some of them are for encouraging research amongst undergraduates so that they can get used to the research space when they move forward. The others are more competitive in nature, like the high performance computing groups. We've won practically 5 of the 7 events internationally. We've won every single local event internationally, placing in the top 2 or the top 3. So if you are interested, just keep an eye out on Moodle. There will be more information communicated to you. My 2 interest groups, quite busy starting to migrate to the online setting. You will hear from the other lecturers as well that it's quite difficult moving online with a lot of these things because you want to have hands-on interaction, but we'll make it work. We are all scientists after all. So hopefully you have your research questions and your playground ready for you to work and have fun, and welcome to 2021. Cheers.
Cool.
Thanks.
Yeah, go for it, Brandon. Thanks. Yeah.
Sorry. Yeah, so as MJ says, we have offered quite a few different interest groups over the years now. And I'd just like to quickly talk to you about a couple that I run. So these are obviously outside of the normal curriculum. And the first one I've started and have been running for a couple of years now is called AI Beyond Gaming. And obviously with how the name is, it's to do with gaming and the different AI techniques that have been utilized for gaming. And along with that, we've actually started doing a little bit of game development within the group itself. So, making our own games in Unity. But in general, it's just about, talking about the interesting things and how they relate to like computer science and algorithms and how they've been utilized in the gaming world. So that's the one. The second interest group that I run is to do with RoboCup. And RoboCup is a robotics AI competition that's run internationally. And we look to compete in that each year in the Simulation League. So basically, we're just designing AI or AI behaviors to create a team of simulated soccer playing robots. So that's also a lot of fun. And with that, we've, over the years, we've been able to travel abroad to like France specifically, to meet other teams. And that's also a great experience to be a part of. Now, these interest groups will be kicking off once like the email lists, for example, are formalized, and I can start emailing notifications and when we meet and stuff like that. So keep an eye out for more information to come in those regards. Otherwise, I teach one of the third-year courses, as Richard said. So hopefully I'll see you guys all in a couple years. But yeah, that's all from my side.
Thanks. Steve, could you maybe chat about the competitive programming?
Sure. All right. Hi, everyone. My name is Steve. While I'm talking, maybe I'll just also chat a bit about the course. But in terms of the interest groups, so I organize and run the competitive programming interest group. And the idea behind competitive programming is saying, programming as a competition. So you're given a set of problems and you're given a fixed time limit, and you have to solve as many problems as you can, as quickly as you can, and you work as a group. That's basically the gist of it. If you did kind of like, say, the computer Olympiad back in high school, if you did the maths Olympiad, it's that kind of thing, but for programming. And we generally compete in at least 2 competitions a year. The one is the Standard Bank Technology Impact Challenge. And so how that one works is we have local heats at WITS. The winner of those local heats is then invited by Standard Bank to their like fancy resort, along with the other universities in the country. And there's like nine competitors in all, and they compete in the final, and then the final takes place as a team exercise, and the winners win a lot of money and things like that. So that's one aspect. And the other competition is what's called the ACM ICPC. And that's an international competition, and there are heats for different regions of the world. So there's like a European heat, an Asian heat, an Africa and the Middle East heat. And that usually happens around October. And the winners from there get invited to the world finals to compete. So that's roughly speaking the competitive programming interest group. We also have kind of like other competitions that happen over the year, online things. Recently, Google had what they call their hash code, which is a competition. Later on in the year, they'll have something called Code Jam, again, which is like an individual programming competition. And there's various other ones that occur throughout the year. There's one from Intellect where you essentially have to create a solution or an artificial intelligent agent to play a game, and those kind of things. So if you would like to join, it's still not clear, obviously, with the COVID situation, whether certain competitions will and will not run. So I will keep you updated on that. Again, it's open to everyone. Obviously, if you haven't programmed before, in class, we'll learn how to program. And then if you're passionate about things, there are many resources online for learning and practicing. And you're more than welcome to join these groups. Other than that, so that's the interest group. Other than that, just to quickly introduce, I will be your lecturer for the first year, Comms 1018, Comms 22, Introduction to Algorithms and Programming, which the first lecture will take place tomorrow. And there'll be a video just explaining a bit more about that. And then maybe I can quickly share my screen, just to give you some idea. So my name is Steve. As you've seen, these are names that people have addressed me by in the past. I know everyone likes Steve Ovo. So, you can go with that. But please try not to call me things like sir and professor, because I'm having a bit of a crisis about my age. So I want to feel young again. Anyway, so that's my name. I'm a researcher here in the department. My interests are, and I'll talk about this in the video tomorrow, revolve around something called reinforcement learning, which is a subset of artificial intelligence. And that's kind of what I'm passionate about. So on one hand, I do research in AI, and then on the other hand, I teach first-year classes, and I'll also be teaching the third-year class for advanced algorithms. And yeah, that's about it for now. Like I say, we'll chat more in the video tomorrow, and then hopefully when you guys join the Discord group, we'll get to know each other a bit better. But I think that's about it.
Cool, fantastic, thanks. I want to highlight one question that popped up. Also, I've just figured out how to do this on Streamyard, which is pretty cool, that we can see this question. So the question was, can a first year join these interest groups, even if you haven't started coding yet and you haven't done that stuff? And the answer is absolutely yes, please do so. If you are interested in any of these things, if you're interested in the gaming, in the high performance computing and competitive programming, and in any of the other interest groups that we'll be running, please do join them. We encourage you to do this. The whole point of them is to bring people together that have a similar interest, and then everyone can learn about them and get better at it over time, right? And so competitive programming is perhaps a good example where if you haven't coded before, maybe you feel like that's not for you, but actually doing competitive programming allows you to get much better at coding because you get all that extra practice, right? So please do go ahead, join these groups. We will be sending out more information, and there'll usually be probably a Moodle course and perhaps even a Discord server for each of them that will be communicated to you at different times. Okay, great, cool. Okay, so then from here, I'm going to ask Dr. Pravesh Ranchard. He is the postgraduate coordinator, and he's going to just chat a bit about some of our postgrad programs, some of the kind of programs that you can go into as you kind of work your way through the system, and then just some of the cool ideas and some of the cool research that's taking place in the school. Thanks, take it away.
Hey everybody, I'm Pravesh. Can you all hear me? I'm going to assume that's a yes. That was a very silly way of asking a question.
Yep.
Okay. So the first thing I want to do is congratulate you. You are clearly a person of taste and discernment because you have decided to do computer science with us. Now, when we sort of publicize computer science in a South African context, we talk about a 3-year degree, right? So you've got a 3-year BSc that you're going to be completing in a record 3 years. And this is quite specific to South Africa, actually. In most countries, computer science is a 4-year degree. So what that means is that in most cases, you'll be doing your 3-year BSc degree and an honors degree, right? And so I'd highly encourage you to think of it that way, even under the circumstances you're in, which is South Africa, in that you should, unless there is a very compelling reason not to, you should do honors immediately after your degree to sort of make up the 4-year degree, okay? And Dr. Hairong Wang, who's also on this call, is the coordinator of the honors program and will be able to provide you with more information about doing honors. And hopefully we'll have a class of 400 in honors in 4 years, in 3 years, which would be nice. And then after you do honors, you can go into a master's in computer science or a master's in data science, a master's in AI, a master's in robotics. And for the master's in computer science or the master's in robotics, you generally speak to me. I'm the coordinator of that program. For the master's in data science and AI, you'll be speaking to, I think it's Richard and Hairong. Correct me if I'm wrong there, Richard.
Richard and Hema.
Richard and Hema, okay. And after you do a master's, you can continue to a PhD in computer science. And there I'm the coordinator as well, so you'll be speaking to me. Now, the thing about these postgraduate degrees is that you'll be doing research. And at the moment, you probably have a very unclear idea of what research is. The idea of doing research, as you'll be doing in postgrad, is to answer questions that no one has answered before. Okay, so it's not about finding stuff out, which I think is a pretty good informal definition of research. But for postgraduate science research, we're generally saying we want you to find out stuff that nobody knows, meaning you can't look it up, you got to figure it out. And in computer science, we've got a number of research areas which are actually pretty cool. As MJ mentioned, high-performance computing is an important one that we take quite seriously, and we do quite well in in an international context. And what high performance computing is this idea that you can get multiple computers to work on the same problem. Okay, so if you've got a really difficult problem, instead of throwing it at a single computer, you could throw it at thousands of computers and hopefully have it done thousands of times faster. And this seems like common sense, right? It seems like if I use 5 computers, my program will run 5 times faster. But that's not strictly true. You guys have all had group projects in school, I'm sure. And you'll have found that if you had a project that you had to do with one person, it would go pretty fast. And if you had a project that you had to do with 5 people, it would suddenly take a whole lot longer. And the reason for that is that all the coordination and communication you have to do in a group takes time. And this is not different for a computer, right? Computers have to do exactly the same thing. Another quite powerful area in computer science right now is machine learning. And it's another big focus of the school. And this is the idea that computers can get better at stuff by learning from observing stuff. Okay, so what that means is that instead of us telling computers how to do things, they'll figure it out. One powerful spin-off from this is that once they figure out how to do things, they can in future figure out how to do them even better. I suspect a number of you are gamers, and one example I like to use, which gets worse and worse every year, is the example of FIFA 99. Now, yes, that does mean I was playing FIFA in 1999. And if you were, you will have noticed that you could always score against the computer by running to the corner flag, putting in a cross, and heading it in. And there was just nothing the computer could do. It hadn't figured out how to counter that strategy. So you'd get right onto the corner flag, you'd make a cross, and then you'd score every time. And this was because the computer had no ability to adapt. Right. So one of the things machine learning does is it gives computers the ability to adapt and to figure out what it is that we're doing badly and figure out how to do them better. Okay. But I think more importantly, the key in computer science is that it's now become a sort of super science, if I can put it that way. Now, granted, I'm biased because I am a computer scientist, but most sciences now involve a large degree of computer science. So if you're interested in, for instance, the biggest breakthroughs in biology, you're going to find that there were computer scientists involved because everything's computer science. If you're looking at the biggest breakthroughs in physics, you're going to find there's computer scientists involved because everything is computer science. Okay, so we've gotten to the point now where whatever field of science you're interested in, and whatever field of human advancement you're interested in, computer science is the way to get there. Okay. Now, importantly, computer science is not it's not about necessarily how do I say it? It's not about necessarily overworking yourself. And I want to say that just from the point of view of, I just said everything in the world is computer science. I always say to my students that I feel like the number one characteristic of a computer scientist, or at least of a good computer scientist, is laziness. And if you speak to any of my students, they'll tell you that I live that principle pretty strongly. And the reason I say that is because what is the lazy approach to things? The lazy approach to anything is not to not do it. Right? The lazy approach to anything is to do it the most efficient way possible. Okay, and you'll find that that's a huge focus in computer science. It's not just how do we get something done, but how do we get something done incredibly efficiently. Okay, and this boils down even to your standard sort of programming exercises, where a fundamental focus of computer science is how do we make things reusable and how do we make them easy to reuse so that we don't have to do work that we wouldn't otherwise have to do, right? And I want to say this in the context of computer science this early, just because it even comes down to your study strategy, right? Because you could say, I'm not going to do my labs because I'm lazy. But how lazy is it to do the course twice when you only have to do it once? That seems incredibly unlazy, right? So the lazy approach is do your labs, learned program, and you'll undoubtedly pass first year, right? So, so there's a bit of a hack to this, and I encourage you to make use of it. Okay, I think that's pretty much all I have to say. Thank you, everybody.
Cool. Thanks. Great. Okay, great. Yeah, so then there are just watching a couple of the questions coming through. So to reiterate, so the to join an interest group, you do so. We will send out information via email, and so we'll send out emails to everybody, and they'll have instructions in there of what to do, but you'll probably have a link to a Discord server and to a course on Moodle where you'll be able to enroll yourself. Then there was a question about the part-time modules. So the part-time modules, we're running the part-time program in both first and second year this year. While we are teaching online, the full-time and part-time courses will be bundled together. Okay, so the full-time lecturer will be posting materials. In most cases, we are trying to do asynchronous teaching at these levels, and so in the vast majority of these cases, the lecturer will be posting a video. You'll go onto Moodle, you'll watch the video, and then there'll be some assignments and labs and quizzes and things like that to do. So for part-time, just while we're online, everything is the same. And then if we go back to campus later in the year, then the part-time lectures would take place separately in the evenings. But for now, everything is identically the same. Okay. The other question was about the Discord servers, about how to join them. So each lecturer that is using Discord will create a link and paste it in their Moodle course. Okay, so if you visit your Moodle course for that module, and if the lecturer is using Discord, then you'll be able to click the link that they put there. It'll take you to the website. If you have an account, you just log in. If you don't have an account, you can sign up for a Discord account for free. We will also have a general computer science Discord server as well, and I will post the link to that in that undergrad Kazam course on Moodle later on in the week. Okay, great. Cool. Okay, so then I think that covers most of what we wanted to talk about today. I'm not sure if I've forgotten anything. What I do want to go through is just some admin points that are outlined in the computer science in the kind of general computer science undergrad outline. And I just want to point these things out. Note that this, as I mentioned before, this outline applies to every single undergrad course in computer science. Okay, so these rules are standard across the board for every module. And then the specific lecturers will give you a specific course outline for their course. And they may adapt these rules to tailor it for their course if they feel the need to do so. But if they don't talk about something, then the rule is whatever's written here. Okay, so we want to, so in computer science, we split all our years into small modules, right? In applied maths, you just have one course code. You have APPM 1006, and that covers every single applied maths module that you're going to do. Whereas in computer science, you're going to have 4 separate marks that appear on your transcript, one for each of these codes. Okay. What this means, though, is that you could have gotten above 50% average across all those codes, but maybe you got like 46% in Comms 1017, for example, right? And if that happens, what we can do is we look at the overall average and we say, is your full average high enough? And if it is high enough, and that the course that you didn't do so well in wasn't too bad, then we can give you something called a P-min, right? It's called a pass with minimum requirement. So the rule for this is that, here's the rule. So you have to get, down here, yeah. So you have to get between 42 and 49% in the module that you're hoping for a P-min in, right? So if you get below 42% in a course, there's nothing we can do to help you. The average in those in all of your comms modules must be above 50%, right? And we are only allowed to do this if it's one module. Okay, so we can't do it if you fail 2 modules or something like this. And really what happens is the idea of a P-min is that it allows us to help you when there's like one module that would add extra time to your degree. Okay, so it's not that you automatically qualify for P-mins in general, but that if the Board of Examiners looks at your case and says, look, there's just this one module. If we give you the P-min, it's going to save you a year of studying, plus you were really, really, really close. Okay, then you can get that code. If you do get a P-min, right, it is the same as if you passed the course. You get credit for the course, and you can continue to study any of the other courses that depend on it, right? So if that's a prerequisite for something. Some of the other ones that are important to know, you get one called an FCOM. An FCOM would mean that you fail a compulsory part of the course, right? Similarly, you get an F-sub, which is also a similar kind of thing, right? So, but the idea of both of those is that if you fail something that's really, really, really important in the course, then you don't make it through that course, and you would potentially need to repeat it. So one example is in Introduction to Data Structures and Algorithms in Comms 1017. There are 2 parts to the course. There's a theory part and there's a practical part, right? And so it's really important that before you move on to second year, that you are both able to program, right, which is the practical part, and that you're able to do the theory and the complexity analysis, which is the theory part, and those are both things that you're then going to need to do in second year, right? So if you get below 35% in either of the lab or prac exams in that course, for example, then you are potentially at risk of an FCOM. Okay, so if those, so that's just an example of when it might be used. Some courses use them and some don't. But the lecturers will specify in their course outlines exactly what the requirements are there. Okay. Likewise, to qualify to write the exam, you need to get something called satisfactory performance, and satisfactory performance means that you have done enough of the course beforehand, right? So if your course mark is below 35%. If your year mark, for example, going into the exam is very low, then you may not qualify to write the exam in some cases. Similarly, you have to attend 80% of your tutorials and submitting labs and quizzes and things like that, right? So that rule is written down here. Right, so just make sure that you are doing your assignments. Don't skip them. Don't leave them all out. You need to have completed more than 80% in order to qualify to write the exam. Okay. Other ones here. Another big one to point out is that you must write your exams. Okay. If you just don't pitch for an exam, right? Even if your year mark would have been high enough to pass, you would fail the course and you would need to repeat it. Okay, so don't just not pitch for an exam. Always write it. Or if you have a medical problem or something like that, apply for the deferred, and then definitely write the deferred. Don't skip that one. Okay, so I suggest just looking at these things in a bit of detail. In terms of missed work, there are 2 different things that kind of go on. So there's missed work where it's something inside the school, where it's maybe you miss a test, you miss a lab or a quiz, something like that. Then we have a missed work form that will be available in each course. right? So each course will post a copy of the missed work form as well as like a submission, right? So you can have like a little Moodle submission where you can then fill out the form and submit it into your lecturer. Okay. When you do that, you must provide some kind of supporting documentation, right? And so if you are ill, then you need to submit a scan or a photo of a medical certificate, right? So a thing from the doctor. We recognize that there are other things that go on now, and with COVID and kind of everyone working online and from home, that there are issues where you might have connectivity problems or data problems or things like that, okay? If that's the reason that you missed something, right, then you still need to fill out one of these missed work forms, and then you must attach proof, and we will accept a police affidavit for that, right? So you can go to a police station and fill out an affidavit, and then you're making like a sworn testimony that you're not lying about that. So anything where it's just a little bit more complex to get proof, please submit a police affidavit. You must submit these things within 3 days of the deadline, okay? So don't wait 3 months and then send your lecturer an email saying, I missed the first quiz, please can you help, right? We do need to know this information up front, and it's really important that we get this information early, because that's how we can help you, okay? If we find out all these things later, then unfortunately there isn't stuff that we can do. Okay, so when you submit those forms will then go to the Teaching and Learning Committee generally, and the committee will check that these are all sensible and that things are applied properly across the school. Okay, if you don't submit a missed work form, or if you don't submit proper supporting documentation with it, or if the reason that you missed it is spurious, then unfortunately you would get 0 for that assessment. Okay, so that's the one part, and those things are managed inside the school. Okay, if you miss an exam, now exams are things that are scheduled by the exams office. There'll be a proper exam timetable that gets released by WITS Central. Okay, so that's not from the school. Those dates and times come from WITS. Those exams will, at first year level, will be online. At like second, third, fourth, fifth, sixth year, some of those will be in person. If you miss an exam, then you must apply for a deferred through the faculty. And that means, I think you log into your self-service portal and you can apply for the deferred through that. Okay. Again, faculty also requires that you do this within 3 working days of that missed exam. All right. If you apply late, or if you don't give them proof, then you're at risk of getting that fail absent code, and then you would need to repeat the course going on. All right. Submissions. So all submissions should be made using the lecturer's preferred channel. So every lecturer will tell you whether you'll see whether you're using an Ulwazi site or whether you're using a Moodle course, right? At first year level, everything is on Moodle for computer science, but in some of the latter years, there's a bit of a mix. So you must submit using whatever instructions the lecturer gives you, whether that's Moodle or Ulwazi. If you submit using the wrong channel, if you try and email it to the lecturer instead of submitting it via the platform, then unfortunately those submissions won't be accepted. Okay, and just note that some lecturers may ask you to write out assessments on paper. Right. So if for example, you're doing some kind of mathematical proof or something like that, they might ask you to write it on paper. And in that case, then you should scan it if you have a scanner, or if you don't, you can use an app like Cam Scanner. That one's free, that allows you to take photos of all the pages, and then it just enhances the quality a little bit and gives you a PDF that you can then upload. Okay, so it's worth figuring out how to do that now, so that when a lecturer does ask you to do it, then it's already kind of easy to do. Okay. The next thing is just kind of general queries and issues. So when you are talking to your lecturer, your tutor, a coordinator, anyone, please make sure that your student number is always there. Okay. So if you are emailing from your WITS account, then obviously that's your student number at WITS. But if you use another address or something like that, just make sure your student number is there. It makes life a lot easier for lecturers because they can then look up all your details. Otherwise, we can't really help with queries, right? For general curriculum and registration type queries, okay, you should go to the course coordinators. So those are the yearly coordinators here. So for first year, it's Steve. For second year, it's Ritesh. And for third year, it's Brandon, right? And so you can just go speak to those, email those coordinators, and they'll be able to help you. Usually, if you're doing like a registration amendment, there'll be a form from faculty that they will then, that the coordinator will need to sign. If you are having like an academic issue, then the first thing is to speak to your tutors and to your lecturer. Okay, so go in, speak to the tutor and lecturer, and they will be able to help you more with that. Okay, if you are having issues in generally kind of the chain of people that you should approach should be your lecturer and then the coordinator, so the year coordinator and then the undergrad coordinator, which is me. Okay, so if you are having those problems, please approach people in the correct order. Always speak to the lecturer first. That's the correct thing to do. And then finally, I want to speak on academic integrity. I would like you to read this section properly, right? But just know that you're at university to learn, right? And if you're copying from people, if you're copying code from websites, if you are cheating in different ways, the biggest thing you're doing is cheating yourself first, right? That if you copy and paste code, you haven't learned anything, and that will catch up with you, right? So when you go in, if you do that now in first year, and then you go into second year programming, I guarantee that coding is going to be harder, and those algorithms are going to be harder. And likewise in third year, that coding and algorithm will be harder, right? And so you need to make sure that you get that foundation done properly now. And as soon as you kind of start copying code, then you're kind of on a dangerous slope. Okay, so the big thing is that it's bad for you.
Richard, if I can cut in there for a second.
Go for it.
So I just wanted to say that in keeping with the idea that the fundamental characteristic of computer scientists is laziness, let's think about what the lazy approach is here. So if you were to copy your labs, and starting early on, you copy some of your labs, then that means you've got to find new and innovative ways to cheat for the rest of your life. Meaning every time you get something to do with programming, and this is going to be your career, so presumably for the rest of your life, you're going to have to find some creative way to not do it, some creative way to cheat the system, right? And that's incredibly hard. On the other hand, you could spend a little bit of time learning to program, and you'll just never have to do that again. So the really lazy thing to do is to actually just learn to program.
Yeah, absolutely right. To add to this now, so that's the carrot. The stick is that we do check for plagiarism. Okay, we have there are two systems that are up and running, and they are much more integrated into our systems now than they were previously. So for older students, this is worth knowing as well. There's a programming plagiarism detection tool that was written by Stanford. It's called MOS, and what it does is it allows us, where we take all of the code, and Moodle will automatically send every submission to MOS, and MOS will send us back a list of any code that looks suspiciously similar, right? Now, MOS knows the programming language. So it knows that it's C++ or Python or whatever. And so it knows that if you change variable names, it doesn't matter. It knows that if you move functions around or change function names, it doesn't matter, right? And so taking someone else's code and then refactoring it to look less like their original code, the system will still find that, okay? And as I say, Moodle will now be automatically sending programming assignments to MOS, and so every single assessment will be checked. And we do take this very, very seriously. So in previous years, what we have done is we have FCOM students for plagiarism, which means that they fail the course, right? And so that would mean now that you would need to repeat a module next year because you maybe cheated in one assignment, right? So that it's really, really not worth it. Please make sure that you are doing your own work. So the question is then, okay, well then how do you work with groups? How do you work with friends? Like what's the correct way to do that, right? And the answer is that if you are asking for my help, right, you are not allowed to look at my code, right? So perhaps I've already finished my assignment and I'm able to help you in some way. I can perhaps look at your code and I can be like, okay, cool, like that's where your bug is, and then you can go fix it, right? But if I show you my code, then it's too easy to copy, and you do end up copying, right? So that's the one thing. Then the other part of this is know that if you show your code to someone else and they submit that code as theirs, you'll both be flagged for plagiarism. Okay. So and those ones will be upheld, right? So so don't spread your code around. You know, if you are someone who's finished your assignments already and you're very confident and you know it's potting and you want to help people, help them via the Discord, help people in your type groups, definitely do that. Work in study groups and stuff like that. But don't give people your code, okay? Because it does happen where someone has your code and they submit it, and now suddenly you're also in trouble. Okay, so please, yeah, be very careful of that. Likewise, also don't post the solutions to your assignments and stuff. Don't post them publicly on something like GitHub, where the rest of the class can see it as well. Okay, because you'll also end up getting flagged unnecessarily. Great. I don't know if anyone else has anything to add. Yeah, one last thing. This is probably less relevant for first years. But so the Faculty of Science has released the science activities sheet. I have put a link to this online spreadsheet under the Moodle course for undergrad Kazam. I think I put it up. If I haven't, I'll put it up as soon as this is done. You'll see that Kazam is listed here, and this shows you what in-person activities are planned for all of the different modules in the program, right? So in first year, everything is online for the entire year. Or at least that's the current plan. It will definitely be the case for the first semester, and we're waiting on announcements from Central Vits regarding the second semester. But at this point, we anticipate that things will be online. In the latter years, you can see kind of in second year and third year, there are instances where you have kind of computer lab-based tests and face-to-face exams. Okay, so if anyone is taking any of these kind of second, third, fourth year modules, please check out the sheet and make sure that you know which weeks you may be expected to be on campus in person. Okay. Obviously, if the pandemic, however the pandemic evolves, some of the face-to-face assessments might need to move online if that's the case. But assume that these things are face-to-face unless you are told otherwise. Okay, but as we say, for first years, everything is online. Okay, great. So I think that is everything that we wanted to cover today. I hope that we've managed to answer all your questions. If there are other questions coming through, we're perfectly happy to help with that. I will make sure that the link for the Discord, the general computer science Discord, is up within the next half hour. And so you can join that Discord server, and we'll all be available on that Discord server periodically and answering questions and stuff like that there as well. Okay, so once again, welcome to WITS, welcome to Kazam. Congratulations on making such a good decision to come study computer science here with us. And it's exciting to kickstart the year. And yeah, we look forward to interacting with you in your courses, in the interest groups, via email, and then hopefully sometime soon in person. Okay, so in the meantime, everyone, please stay safe, look after yourselves, and we will see you in class soon. Thanks very much.